Hi, I'm George Woodbury from College of the Sequoias in Visalia, California. And in this video, we're going to graph quadratic functions of the form f of x equals ax squared plus bx plus c. So not in that hk form. When the function is of this form, we know that the x-coordinate of the vertex is given by negative b over 2a. And then we can plug that value back in to figure out the y-coordinate. Where that comes from, real quickly, is if you complete the square for this function, you will get f of x equals a times x plus b over 2a quantity squared plus 4ac minus b squared all over 2a. And so there is where we get our value for h from, x minus negative b over 2a. And then this value at the end there would be k. I don't think that memorizing that formula makes a lot of sense. We'll just plug that value back in to get the y-coordinate. So the first thing I want to do is I want to find the vertex. So here, the vertex, x equals the opposite of negative 4 over 2a, which is 2 times 1. That's positive 4 over 2, or 2. And when we plug that back into the function, f of 2 equals 2 squared minus 4 times 2 minus 12. We get 4 minus 8 minus 12. And that equals negative 16. Now I'm going to be in a little bit of trouble here because my graph only goes to negative 10, but I'll show you how we'll work that out. So there's the vertex, 2, negative 16. And so what I'm going to do is I'm just going to extend 11, 12, 13, 14, 15, 16. There's our vertex at 2, negative 16. Now let's come back. That graph is going to open upward because the coefficient of x squared is positive. It's a positive 1. That indicates that the graph opens upward, and that also tells us that the graph has to cross the x-axis. So next I'm going to look for the x-intercepts. And just like in the other form, the x-intercept, we solved f of x equals 0. So here, that's going to be x squared minus 4x minus 12 equals 0. Instead of solving by the square root property, we can use either factoring, we could use completing the square, or we could go right to quadratic formula. Here, this one does factor, and so if you can't factor it quickly, and I would say like 5 or 10 seconds, then you want to jump to quadratic formula. But if you can factor it quickly, this is x minus 6 times x plus 2. I can get the solutions really fast from there. This gives me x equals 6, so that's the point 6 comma 0. The second factor gives me x equals negative 2 comma 0. And so I'm going to put those on there. And let's take a look at what we have so far. The next step for me is to find the y-intercept. And the y-intercept, let's continue over here. The y-intercept, we just have to find f of 0. So I'm going to put in 0 for x. F of 0 equals 0 squared minus 4 times 0 minus 12. Well, that's some easy arithmetic because all the zeros disappear and we just get negative 12. So 0, negative 12 is the y-intercept. Let's put that on the graph. That would have been about there. And its mirror image point would be over there. I can use a little bit more about parabolas. So this will behave just like x squared. As we move out by 1, everything will move up by 1. So I could have had a point here and here, say. Now that I've got a lot of points to help me make this a smooth curve, I could substitute maybe x equals 5 because I've got an x value here of 4, and then I've got another one over here at x equals 6, if I got one more point in between them, it might make it a little easier to connect that. So I'm just going to call this extra, and I'm going to find f of 5. F of 5 equals 5 squared minus 4 times 5 minus 12. That is 25 minus 20 minus 12, or negative 7. So 5, negative 7 is on the graph of this function. 5, negative 7. I can use symmetry to go 5 to, this was 3 to the right of the axis of symmetry. So if I go 3 to the left, 1, 2, 3, get another point there. Now I've got a lot of points to work with. Let's just draw the parabola. Most important thing is to make sure that the bottom of that parabola is round and not V-shaped. Again, take your time with that, but there's the graph, the domain, just like the last type, all real numbers. The range, how low does it go? It went down to negative 16. How high does it go? It goes forever. So that's bracket negative 16 comma infinity. Just want to show you a little bit about completing the square to show you that we would have got the same graph if we had converted it to the other form. So I'm going to take the function f of x equals x squared. Let's see, it was minus 4x minus 12. And I'm going to complete the square on that. So the first thing that I'm going to do is I'm going to write x squared minus 4x, leave some room in the parentheses, and put the negative 12 outside the parentheses. Half of negative 4 is negative 2. Negative 2 squared is what I'm going to add inside the parentheses. Negative 2 squared is positive 4. So I put a plus 4 here to keep that side equivalent. If I'm adding 4 in the parentheses, I need to subtract 4 somewhere else. I'm going to do that outside the parentheses. And what I end up with is x minus 2 quantity squared minus 16. And there's where our vertex comes from. H is 2, K is negative 16, and that's what we had for the vertex. Then we could go about finding the other intercepts and so on, but I just wanted to show you that they're equivalent, even though we're using a different strategy to get the X-intercepts, etc., the vertex. They're equivalent. I've got a couple more for us to do. The second one, A is 2 instead of 1. This would not be a lot of fun for completing the square on, but we can avoid that. First, the vertex. And again, that is where x equals the opposite of b over 2a. Here, that's going to be x equals the opposite of negative 1 over 2 times a, which is 2. We get positive 1 over 4. So the x-coordinate of the vertex is 1/4. To find the y-coordinate, we're going to find f of 1/4. And that's going to be 2 times 1/4 squared minus 1/4 minus 3. 1/4 squared is 1/16, and 2 times 1/16 is 1/8. 2/16 or 1/8. So I've got 1/8 minus 1/4 minus 3. I want to get a common denominator here so I can get that together in one fraction. So I'm going to multiply the second fraction by 2, top and bottom, to get its denominator to be 8. And then for the last number, negative 3, I'm going to think of that as negative 3 over 1, and I'm going to multiply top and bottom by 8. So all of our fractions are in terms of, have a denominator of 8. So I've got 1/8 minus 2/8 minus 24/8. And this is negative 25/8, or negative 3 1/8, or negative 3.125. So all just a little lower than negative 3. So 1/4, I'm going to write the mixed number, negative 3 1/8. How do we get that on the graph? Well, let me blow it up first. So 1/4, if I divide the 0 to 1 interval with 3 lines, that makes fourths, right? 4 pieces. 1/4, 3 1/8. That would be around here. So really close to the y-axis and just a little bit below -3 for y. So we've got that point on there. Let me make that just a little bigger. Next step is to find the x-intercepts. And this function opens up because the coefficient of x squared is positive. That means it opens up. That means that starting below the x-axis, it has to cross it at some point. So we can look for the x-intercepts. Set the function equal to 0, or where y is 0. 2x squared minus x minus 3 equals 0. And you may think about going to quadratic formula here, but this one factors to be 2x plus 3 times x minus 1. If you FOIL that back out, 2x times x is 2x squared. 2x times -1, that's a negative 2x. I've got my signs backwards. I'm glad I'm checking this. 3 times x, that's a positive 3x. So together they make a positive x. And then finally, 3 times -1 is -3. So I had everything right there. I just missed the sign. So let me make a quick change. That's going to be x plus 1 and 2x minus 3. The first factor gives me x equals 3/2. 2x minus 3 equals 0. Add over the 3. We have 2x equals 3, and then you can divide by 2 to get that solution. So 3/2 comma 0. That's at 1.5 on the x-axis. The other one, we get to x equals -1 pretty quickly. -1 comma 0. That's over here. The y-intercept, when it's in this form, is a lot easier to find. We put in 0 for x. So f of 0 is 2 times 0 squared. That's 0. Minus 0. That's still 0. Minus 3. We get out -3. So 0, -3. And by symmetry, we get 3 points. Looks like Mickey Mouse ears when we're zoomed out. But when we zoom in, we can see that there's really 3 points here. You can find more points if you want to, but we can draw it from here. It looks something like that. Now, for the domain, as all the other examples, that's all real numbers, but the range, it drops down to -3 1/8. So bracket -3 1/8, comma, infinity. All right, let's try one more. I've got one more example. This one opens downward. F of x equals -1/2 x squared minus x plus 4. So let's start with the vertex. X equals the opposite of b over 2a. For this example, that's going to be the opposite of -1 over 2 times a, which was -1/2. The opposite of -1 is 1. 2 times -1/2 is -1. So we've got 1 over -1, or -1. Let's plug that back in. F of -1 equals -1/2 times -1 squared minus -1 plus 4. -1 squared is +1. So this first term is -1/2 times +1, or -1/2. Minus -1 is the same as +1 plus 4. And what we end up with here is 9/2, or 4 1/2. Or you can think of that also as 4.5 exactly. So -1 4.5. Because a is negative, that means that the parabola opens downward. Going downward from there, we do cross the x-axis. So the next thing we'll do is find the x-intercepts. X-intercepts are where the function is equal to 0. Negative 1/2 x squared minus x plus 4 equals 0. I'm not really happy about working with a negative coefficient for x squared or fractions. So I'm going to multiply both sides of this equation by negative 2. And what that's going to do is it's going to clear the fractions, but also make x squared positive at the same time. Negative 2 times negative 1/2 is positive 1. So we have positive 1x squared, or just x squared. Negative 2 times negative x, that's plus 2x. Negative 2 times positive 4, that's negative 8. That side is still 0. Now I can factor this. I know how to factor this one. X plus 4 times x minus 2 equals 0. X equals negative 4, or x equals positive 2. So the intercepts are negative 4, 0, and 2, 0. Negative 4 on the x-axis and positive 2 on the x-axis. Let's find the y-intercept. That's where we substitute 0 in for x, so we're going to find f of 0. F of 0 equals negative 1/2 times 0 squared, 0, minus 0, still 0, plus 4. That equals 4. So the y-intercept is at 0, 4. We can use symmetry to get another point on the other side of the vertex. And that negative 1/2 tells us that the first step out only drops us by 1/2. The second step out was supposed to drop us by 4. Half of 4 is 2. So from the vertex, if I move over 2 and then down 2, 2 to the left and down 2, I get a couple more points to work with. Anyway, from there, we get that graph. The domain is the set of all reals. The range, how low does it go? It goes down forever. That's negative infinity, comma, how high does it go? It goes up to 4 1/2. And that gets a bracket. All right, so that's the end of the examples for this type. The major differences between the two types of quadratic functions are how you find the vertex, whether you read it from the equation, or whether you use the formula negative b over 2a to get x. How you find your x-intercepts. With the HK type, we're always going to use the square root property to get those. But with this type that we did in this video, we might factor, we might use quadratic formula. We have a lot of options. Finally, the y-intercept was a little more work with the HK type. Here, it's always going to be that number c at the end, right? When we plug in 0 for x, any term with x disappears, leaving just the constant term. So there's some pluses and minuses to both. What you really want to be is flexible enough to whichever form you're given, you can handle that form. You don't want to have to switch it to another form in order to graph it. All right, that's it for this section. I'll see you in the next section.